Right, so moving on to chapter number 4, which is all about graphs and transformations. As I said in chapter 2, graphs are very, very important and a big part of the maths course. So we need to be aware of all the different types of graphs and any variations that they could give us in the exam. We're going to be looking at cubic graphs, quartic graphs, reciprocal graphs, and also moving them around by. So a cubic function is this one here, where we have this x cubed term, and the general shape of a cubic function will look something like so. Now this shape will vary depending upon certain factors within the original cubic function. So we're going to look at all different types. Right, first things first, we need to identify whether it is a positive x cubed coefficient or a negative x cubed coefficient. This one here, remember, was for a positive x cubed coefficient. If it's a negative one, then it will look something like so. It's just flipped. Second step is to identify where does it cross the y-axis. This is very simple. Just plug in x is 0 into your cubic function and find your y value. Thirdly is now finding where it crosses the x-axis. Now this is where it varies, and depending upon the number of roots, the shape of the graph would also vary. So let's take a look at each type. The first type is when we have 3 unique roots, i.e. we can factorize them into 3 individual brackets. In this case, it's just going to cross at each individual root. So for example, if I was to sketch the graph y is equal to x minus 3, x plus 2, x minus 1, well, the roots are going to be at negative 2, 3, and 1. And we know it crosses the y-axis at y is 6 if you plug in x is 0. And so it's going to look something like this. If I was to sketch the function, let's say f of x is x, in brackets x plus 1, y minus x. In this case, the roots are going to be at 0, negative 1, and 1. It's actually going to be a negative x cubed coefficient because if you multiply the x terms, we get minus x cubed, which means that it's been reflected. So as you can see, it's not too difficult. As long as you follow the steps, understanding whether it's positive or negative, finding where it crosses the y-axis, and finding where it crosses the x-axis, then you can pretty much draw most graphs. The second variation is when the function has 2 roots, meaning one of them is a repeated root and another is just a unique root. So in this form here, we have h of x, which is x plus 1 squared times x minus 1. We know it's a repeated root due to this squared term here. So if anything is squared, is known as a repeated root. And so we know the roots are going to be at 1 and minus 1. Now the way it changes the graph over is at a repeated root, the graph will not cross the x-axis, but only touch. Okay, so it would only touch at a repeated root. So if I was to go ahead and sketch this graph, you'll see that it will pass through at x is 1. However, at negative 1, because it's repeated, it's going to touch and then go back. Maybe pause the video and try this question here. Okay, so as you notice, this is also a repeated root because it's x squared. So when x is 0, it's going to be a repeated root, meaning the graph will not cross, but merely touch. It's also got a unique root at x is 2, and it's also a negative x cubed coefficient. So therefore, the graph will be flipped. And so if I was to sketch it, it will look something like so. Hopefully you got this example here. The next case is when there's only one root. So an example of this would be this function here. F of x is equal to x minus 1, x squared plus x plus 2. This only has one root at x is 1 because this second bracket, if we were to work out the determinant, actually comes out to be minus 7, which is smaller than 0. So we know that there's no solution, no root. So the only root is going to be at x is 1 and it's going to cut it. So if I was to sketch the graph like this, it'll cross y is minus 2 and then the graph will look something like so. Another case of when there's one root is when there's a triple repeated root. So something like y is equal to x plus a cubed. In this case, due to the power of 3, this is known as a triple repeated root. And so for example, if we had y is x minus 1 cubed, at x is 1, that's the only root. Now, when it's cubed, it's going to actually cross it again. So that's the general rule when we're drawing graphs. If we have repeated roots and the repeated roots are odd numbers, then it's going to cut the graph. If it's even numbers like squared or to the power 4 to the power 6, then it's just going to touch the axes. So that's the one tip I do want to give you guys. Anyway, if I was to sketch y as x minus 1 cubed, then at x is 1, it's going to cut it and it's going to look something like so. Still following the general shape of a cubic function. Okay, so here are 3 questions that I would like you guys to maybe pause the video now and try yourselves. Okay, first one, we have y is equal to x cubed minus 9x. In this case, we need to first factorize to get x plus 3, x minus 3. It has 3 unique roots at x is 0, 3 and minus 3, and it crosses the y-axis at y is 0. It's a positive x cubed coefficient, so it's going to be like the positive shape, and will look something like so. The next one is y is minus x minus 2 cubed. This is an example of a triple repeated root, right? Which means it's going to cut the axes at x is 2. You notice that it's a negative x cubed coefficient because of this negative sign, so it's going to be reflected. And so it's going to look something like so. And the final one is y is x minus 1 squared times 3 minus x. We have one repeated root and one unique root. So at x is 3, it's going to cut the x-axis, whereas when at x is 1, it's just going to touch the x-axis. It's also a negative x cubed coefficient, so it will be reflected again, and it will look something like so. So that's how you go about sketching cubic functions. So as a summary, first thing you want to do is work out, is it a positive x cubed coefficient or negative? Next step will be find where does it cross the y-axis? And the last step was look at where does it cross the x-axis, i.e. the roots. And depending upon the number of roots and the type of roots, then you have to sketch the graph accordingly. This does take a lot of time and practice to get used to and get the hang of. So I've listed out a couple of questions which are good variations of different types of cubic functions.